Let's use substitution to integrate this here. Now we know substitution's going to work because this expression here, if you differentiate it, you get a quadratic. You get 15x squared, and that's 8x squared, which is close enough. So substitution will work here. Now notice that we have a definite integral, so we have limits, 0 and 1. So we need to change those limits at some point. But let's start by taking our expression here, the bit that's under the square root. It looks like that's the thing that we need to call u. So u will be our 5x cubed plus 3. And I know that because if I were to differentiate that, I get something that looks like the numerator. So du by dx is 15x squared, and dx is therefore du divided by 15x squared. Now, I'm going to need that expression for dx, because I want to replace dx. So if I now rewrite my integration, it's going to be the integral of 8x squared divided by the cube root of u times du over 15x squared. So that's simply that. Now, what about the limits? These limits need to be limits for u and not limits for x. So I can't use 1 and 0. So these 1 and 0 need to change. So what do I put instead of the 1? I need to put a value for u. So it'll be 5x cubed plus 3. So it'll be 5 times 1 cubed plus 3. So that's going to be 8. That's my upper limit. And the same for the lower limit. It's going to be 5 times 0 cubed plus 3. So that's going to be 3. So my limits have changed from being 0 and 1 to being 3 and 8. So these are the limits for u. So now my integration's almost ready. What remains is to notice that this x squared cancels with that x squared. So I can now write my integration as the integration from 3 to 8 of 8 divided by 15 times 1 over the cube root of u du. Now, the cube root of u is simply u to the power 1 over 3. And if we bring that up to the numerator, so if you write it in index form, my integration will look something like this. I can bring my constant, the 8 over 15, I can bring that outside the integration. And then I have the integration from 3 to 8 of u to the power negative 1 over 3 du. Now, it's easy to integrate because you have the power, you just need to add 1. So the answer will be u to the power minus 1 over 3 plus 1 divided by negative 1 over 3 plus 1. So negative 1 over 3 plus 1 is 2 over 3. And you divide by 2 over 3. And you've got 8 over 15, don't forget that. We've got this constant that we need to include. So we can, don't forget to put the limits. So we've got limits from 3 to 8. Now, we can simplify that. That becomes 4 over 5. So My integration is now four over 5 u to the power 2 over 3, and my limits are 3 to 8. So remember, with the limits, you need to substitute your upper limit, then substitute your lower limit, and subtract the 2. So you'll have 4 over 5 times 8 to the power 2 over 3 minus 4 over 5 times 3 to the power 2 over 3. So that's your final answer. You could simplify it. Calculator, you get 1.536. So to 4 significant figures, that's your final answer. So depending on how they want your answer to how many significant figures, that's how you would answer it. So things to remember: when you're integrating using a substitution, make sure you change the limits if it's a definite integral. And don't integrate until you've cancelled, or you've eliminated, you've removed all instances of x. When you have a constant, that's okay to remove that outside the integration, and make sure you change all surds into index form. And when you substitute your limits, you substitute the upper limit first, then the lower limit, and then you subtract. That's important.